Well, it's time to learn about absolute value inequalities. Let's begin by looking at a couple of simple absolute value inequalities. We will show the solution set on a number line. Graph the solution set, then write your answer in interval notation. So let's start on the left of the number line and let's substitute in -5 is the absolute value of -5 less than 3. Is 5 less than 3? That's a no. So we're not going to include that point. What about -4? And that's a no. What about -3? 3 is not less than 3, but we're getting very close to -3, but not including it. So let's try -2. The absolute value of -2 is 2. 2 is less than 3. So I'm going to put dots on all of these values that will work. But 3 is not less than or equal to 3, so that is why there's a parenthesis on there. So we can see that everything in between -3 and 3 is a solution. So our answer would be the interval -3 to 3. Now let's look at number 2. We have the absolute value is greater than or equal to 2. Same thing, we're going to plot our points on a number line to see which values would make this true. So again, let's start with -5. Is the absolute value of -5 greater than or equal to 2? Is 5 greater than or equal to 2? Sure is. And so is -4, and so is -3. What about -2? And in this case, 2 is greater than or equal to 2, so we'll put a bracket on it. But -1 would not work. 0 wouldn't work, 1 wouldn't work, but again, would pick up at 2, 3, 4, 5, and so on. So if I color in my number lines, and I write my answer as an interval, I can see that the values from -infinity to -2, including -2, and there's a gap, and then we'll pick up again at 2 and go to +infinity, will make that inequality true. So we have an absolute value is greater than or equal to 2. Greater kind of sounds like an or, and the graph kind of looks like a graph of the compound word or. Number 1, we have the absolute value is less than, kind of sounds like an and, because we were shading in the values that were in between. Keep that in mind. All right, let's look at the definition. Absolute value inequalities. So let K be a positive number. So these K's are positive numbers. If the absolute value is less than K, then we can solve it by taking the opposite of K and basically putting it in front of the inequality. So we have the negative K less than what was in the absolute value signs and then is less than K. If we have the absolute value is greater than K, then we're going to split this up into two inequalities. We'll take the absolute value signs off, flip or reverse the inequality sign, take the opposite of K. Write the word or, take the absolute value signs off, and solve as is. Similar statements can be made for inequalities using less than or equal to or greater than or equal to. All right, let's practice. If we have the absolute value of x is greater than or equal to 6, the absolute value is greater. We're going to look at number 2 up there. So we're going to take the absolute value signs off, flip the inequality sign, and take the opposite. Write the word or, take the absolute value signs off, and solve as is. So we have our interval right here. We're going from negative infinity to negative 6. There's a gap. We'll pick up again at 6 to positive infinity. Number 3, the absolute value is isolated and it is less than, kind of sounds like an and. So I'm always going to solve these as a 3-part inequality. Negative 12 is less than 3x and 3x is less than 12. Divide each section by 3. Negative 4 is less than x and x is less than 4. As an interval, we'll write our answer like this. Now, just because I love doing math, I will do this problem the same way that you can do an or statement. You can take the absolute value signs off, reverse the inequality, and take the opposite. But you need to write the word and, take the absolute value signs off, and solve as is. It might be helpful if you draw a number line so you can see what the interval would be. X has got to be greater than negative 4 and less than 4. So again, we're looking for the overlap, and the overlap is from negative 4 to 4. I will be working out all absolute values less than k as a 3-part inequality. Number 3, we have an absolute value greater than 4. So let's take the absolute value signs off, flip the sign, take the opposite, write the word or, take the absolute value signs off, solve as is. So now we write our answer as an interval. X is less than negative 3 as an interval is from negative infinity to negative 3. Or x is greater than 5, which is from 5 to infinity. And that symbol there means union, which just means we have one section of the number line, and then we're going to join it with another section of the number line. Number 4, we have an absolute value is less than. Less than is an and statement. So I'm going to solve this, taking the opposite of k, which is a positive 25. So now it's negative 25 is less than or equal to negative 5x plus 5, and negative 5x plus 5 is less than or equal to 25. Subtract 5. and divide by -5. Recall that when you're dividing an inequality by a negative, you must reverse the inequality signs. So we have 6 is greater than or equal to x, and x is greater than or equal to -4. And I'm just going to write it in ascending order. Note that these two are exactly the same thing. And then to write it as an interval, the answer is -4 to 6, and including both endpoints. Number 5. Number 5, the absolute value is not isolated. So we need to divide both sides by 2. Now that we have the absolute value isolated, it is greater. That is an or statement. So we'll take the absolute value signs off, flip the inequality, take the opposite, write the word or, take the absolute value signs off, and solve as is. Subtract 3. So we know that our interval is -infinity to -8, union 2 to infinity. Number 6, we have an absolute value. We have a fraction inside the absolute value. That's okay, not a problem. We know that the absolute value is less than. It is an and statement. So I'm going to take the opposite of 1, which is -1. And now I'm going to multiply each section by 7, which will clear the fraction. And solve for x. Subtract 5. And divide by -2. Reverse the inequality signs. Rewrite it in ascending order. And write the answer as an interval. Just that simple. All right, number 7, you'll notice A, B, and C have the same absolute value. A is equal to 3, B is less than or equal to 3, and C is greater than or equal to 3. So let's start by working out A. So we have an absolute value is equal to 3. So to solve this, we take the absolute value signs off. Solve as is. Take the absolute value signs off. Take the opposite. Solve each equation for x. So x is equal to 1/2 and x is equal to 2 are the solutions to A. B, we have less than or equal to 3. If you already know the endpoints, then you already know the answer, but I'm going to work this one out anyway. So we're going to have -3 is less than or equal to 5 minus 4x is less than or equal to 3. And divide by -4 and reverse the inequality signs. And write your answer as an interval. And since we know a less than is an and statement, that's what I was referring to by saying if we already knew the endpoints from letter A were 1/2 and 2, that we could write our interval. And likewise, we can do the same thing for letter C, but I'm going to go ahead and work it out. We have an absolute value is greater. Greater means we're going to write an or statement. So take the absolute value signs off, reverse the inequality, take the opposite, write the word or, take the absolute value signs off, and solve as is. And then you might have to draw this on a number line so you kind of see what's going on. We have x is less than or equal to 1/2. And, or x is greater than 2. So our interval is from -infinity to 1/2, union from 2 to infinity. And the reason I point this out is because in my math lab, on the help me solve this, it's possible they're going to solve an inequality with an equal sign first. And then once you get the endpoints, if it's a less than, then you'll write it as an and statement, as in B. And if the absolute value is greater, then you're going to write your interval notation as the union of the two parts. All right, so now we're going to venture down the 0. Since 0 isn't positive or negative, this makes absolute value inequalities interesting. So we have the absolute value is greater than 0. Strictly greater than. Well, we know what is coming out of an absolute value is always going to be positive. So if I just draw a number line, and if I try 0.5, if I try 0.1, any number that is larger than 0 is going to be true. And the absolute value of a negative is a positive. So all these numbers are going to be true. So the only thing that isn't going to make this absolute value true is if it is equal to 0. So our answer is all real numbers except 0, and that's the way you write it as an interval. Letter B, we now have an absolute value is greater than or equal to 0. So because a positive is coming out of that absolute value, and we can have 0 now that it can be equal to 0, then we can include 0. So our answer is all real numbers. What if we have an absolute value is less than 0? Well, this will always be positive. When is a positive going to be smaller than 0? And we have no solution. Because we can't have 0 in there either, because 0 is not less than 0. Which leads us to letter D. The only time this absolute value is going to be true is when what is in the absolute value is equal to 0. So you would set what's inside the absolute value equal to 0 and solve. And in this case, it is 0. So an absolute value that is greater than or less than 0, these 4 cases, just try to think logically and understand what values would make that absolute value inequality true. All right, number 9. Number 9, remember our original definitions said that k had to be positive. Well, k is not positive. K is a -5. So if what's coming out of an absolute value is always positive, when is a positive greater than a negative? Well, a positive is greater than a negative all of the time. So that's why our answer is all real numbers, negative infinity to infinity. But let's just say you didn't notice that from the start and you decided you were going to follow the rules and you're going to take the absolute value signs off, flip the sign, take the opposite, write the word or, take the absolute value signs off, solve as is. So we have x is less than 2 or x is greater than -12. Well, if you graph this on a number line, this is an or statement, less than -2, 5 minus 7 is -2. Less than -2 is going this way, or greater than -12. Greater than -12 is going this way. So you can see that every number on the number line is covered because it's an or statement. So even if you decided to work it out, you would still get the same answer. Pay attention to the word. The word is or, because this is a greater. All right, number 10. We have an absolute value is less than or equal to -8. Again, our rules apply when k is positive. So you should immediately think, something's not right here. Well, again, this is a positive. When is a positive going to be less than or equal to a negative? Never. Therefore, this one has no solutions. And if for some crazy reason you thought you would take the opposite of -8 and put it in front, so we would have 8 is less than or equal to W, and W is less than or equal to -8. when can W be less than or equal to -8, let's say -9, then how can -9 be bigger than 8? Yeah, this makes no sense at all. All right, so we have a quick little summary here. Sometimes the solution set to an absolute value inequality can either be the empty set. If it is the empty set, that means we have no solution. Or it could be all real numbers. And if it's all real numbers, that means we're going from -infinity to infinity. Consider this example. We have an absolute value that's greater than a negative, which again, if we think logically, we have a positive greater than a negative, which is always true. That is why it is all real numbers. And if we consider an absolute value as less than or equal to a negative, again, we have a positive is less than or equal to a negative. And a positive is never going to be smaller than a negative. Therefore, we have no solution. And finally, here's a little summary I will let you read. And that's all I have for this video. Bye for now.